Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 6.2, radian measure and angles on the Cartesian plane. So there's a couple concepts that we're going to talk about today, one of which is something you guys actually might be familiar with grade 11. So in grade 11, you guys were notified about this concept called special triangles. And in grade 11, there were two special triangles that you guys were asked by your teachers to memorize. The first one being the 45, 45, 90 triangle with the sides 1, 1, and root 2. And the second one being the 60, 30, 90 triangle where you had root 3, 2, and 1. So these were the special triangles, but these were labeled in degrees because in grade 11, you guys did it in degrees. Now, in grade 12, we're going to need to know what these triangles are in radians. Now, the good thing about radians, guys, is that the only thing that's going to change are the angles themselves, right? Remember, degrees and radians is only really talking about the angles. It's not talking about the side lengths. The side lengths are going to stay the same for these special triangles because they hold the same ratios. So there's a couple angles that we need to find in radians. One of them is 30, one of them is 45, and the other one is 60. So let's look at these, get them into radians. So to get it into radians from our last unit, we times it by pi over 180. So we know this guy is going to be pi over 6. For 45, we're just converting it to radians. It'll be pi over 4. And for 60, we convert it into radians, and it becomes pi over 3. So these are all in radians. So now when we look at our special triangles, over here, it's going to be pi over 4 and pi over 4. And over here, it's going to be pi over 3 and pi over 6. So this special triangle, guys, I want you guys to memorize this. You want to memorize this, write it down, write it on a sticky note, put it on your laptop or your monitor. This is something you're going to need to know. Even when you're doing a test, it's good to just write these two triangles on the top. Right when you write your name and the date on the test, write these two triangles so you have it as a cheat sheet as you go through these problems. Now, when it comes to, these special triangles, we also have to know something called trigonometric ratios. Okay? So there's certain trigonometric ratios we need to know. The first one is pretty obvious. Sine theta, right? You got cos theta, and you got tan theta. Now, sine theta, cos theta, and tan theta, remember from grade 11, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. In the same way we have these trig ratios, we also have the reciprocal trig ratio to it as well. So for sine, its reciprocal is going to be called cosecant. And all cosecant is the hypotenuse over opposite. So notice how this flips over. So you're just flipping the fraction, and that's how we get that. For cos theta, the reciprocal is going to be secant, which is hypotenuse over adjacent. And for tan theta, it's going to be cotangent, which is adjacent over hypotenuse. And I just want to highlight this because all we're doing, guys, is we're just flipping these guys. And those are your 6 trigonometric ratios. The third thing you need to know is you need to know Pythagorean theorem. Because remember, when we're talking about special triangles, the concept of Pythagorean theorem only applies to right angle triangles. So remember, trigonometric ratios only apply to right angled triangles. If it's a non-right angled triangle, you cannot use these formulas. Same with Pythagorean theorem. They only apply to right angled triangles. And we know Pythagorean theorem to be a squared plus b squared equals c squared. That's how we know it to be. But in trigonometry, we're going to know Pythagorean theorem as x squared plus y squared equals r squared. So it's the same formula, we're just using different letters. Because this formula, it applies to Cartesian planes. So I'm going to show you guys what I mean by this. And some of you guys may already know this. So this is a formula that applies to Cartesian planes. So let's say we have a Cartesian plane like this. And let's say there's a point here. This guy right here is going to be your r. But if I want to find out what this angle is, then I'm going to need to know, I'm going to use this Cartesian plane to formulate a triangle of itself. And that's where the x and the y come, because this is going to be the x and this is going to be the y. So you can see how this Pythagorean theorem is displayed in this, and we have to use the trig ratios of sine, cos, tan, cosecant, secant, cotangent to find out what the angle is. Cool. So there's a couple concepts. The first one, special triangles. We went through that in radians. Remember here we had our conversion. Then we had our trigonometric ratios, which only apply to right angle triangles. So sine theta, cos theta, tan theta, cosecant theta, secant theta, cotangent theta. And then we have Pythagorean theorem, which also only applies to right angle triangles. The fourth concept we need to know is the cast rule. And this is all review, guys. This is all review from grade 11. So you guys should already know this stuff. The cast rule states that this is C, this is A, this is S, this is T. So what do these C, A, S, T means? Some of you guys might already know this. The S represents sine. The T represents tan. The C represents cos. And the A represents all. So what does that actually mean? Over here, whenever you take the sine of any function, is always going to be positive. When you take the cos or the tan, however, these guys are going to be negative. So only in this quadrant, sine is positive. But over here, tan is positive, and cos and sine are negative. And then over here, cos is positive, but sine and tan are negative. And then over here, all are positive. So sine, cos, and tan are all positive. So this is really important, and I'm going to show you how. If I look at this, for example, let's say I had a triangle here, and this was 3, 4, and 5. If I take the sine of this angle, it's just going to be 4 over 5, because it's opposite over hypotenuse, which will be positive. If I take the cos of this angle, it'll be 3 over 5, which is also positive. If I take the tan of this angle, it'll be 4 over 3, which is also positive. So that's why in the all quadrant, if the triangle appears in the all quadrant, or the A quadrant, then you know all of it's going to be positive. But what if I had that same triangle in this quadrant? Then this would be negative 3, this would be 4, and this would be 5. So if we take the sine of the angle, then it would be 4 over 5, because it's opposite over hypotenuse, so which is positive. But if we take the cos of the angle, it would be negative 3 over 5. If we take tan of the angle, it would be 4 over negative 3. And that's why cos and tan are both going to be negative numbers, but sine would be positive. Let's go to the next example. What if I'm in this quadrant? Yeah, that side's going to be negative 3, but then this side's going to be negative 4. The hypotenuse though, guys, the hypotenuse or the r value is always going to be positive. Just that's something to know. And I'm going to write that here. R slash the hypotenuse. Hypotenuse. I don't even know if I spelled that right. Oh, hypotenuse. The hypotenuse is always positive. Okay, the hypotenuse is always positive. So this 5 is always going to be positive. It's only the x and y that can be negative or positive, right? X or y can be either positive or negative. So this is something to know. Let's go to the last quadrant. If we're following the same pattern, this is -4, this is 5. So if we look, cos is adjacent over hypotenuse, which is a positive number. Sine is opposite over over hypotenuse. Tan is opposite over adjacent. So we're going to get negative for both of those as well. So remember the triangles that you have also, the triangles that you have, so these triangles, are all going to be in reference to the x-axis. So notice how the triangle here is in reference to the x-axis, the triangle here is in reference to the x-axis, and the triangle here is in reference to the x-axis. Now, some people confuse this because they just don't know, right? But some people, when they draw their diagrams or their triangles, some people will draw it like this. If you look at this is wrong, okay? Because these are all in reference to the y-axis. So you see how the triangles are sitting on the y-axis? They're all sitting on the y-axis. None of them are sitting on the x-axis. This is wrong. So don't make your triangles like this. If you're going to make your triangles like this, it has to be like a bow. Okay? So they're always in reference to the x-axis. Okay. And the last concept we want to know for this chapter is, what is a principal angle? Principal angle versus what is a reference angle? Okay. So the principal angle, if you look at this, we're always starting in the positive x-axis. So we're going to start in the positive x-axis, which is over here. So this is where we're going to start, the positive x-axis. That's where we're going to start. Now, when we do this, we're going to actually go counterclockwise like this to a certain point. So let's say we land here. So this right here is called the principal arm. This right here is called the terminal arm. The angle they create between the principal arm and the terminal arm, this is what we call as theta, which is the principal angle. And the other angle, so this acute angle, is actually called beta, which is the reference angle. So this is just terminology, okay? Whenever you're doing these equations, you're starting from the principal arm and then you're going counterclockwise. So you start from the positive x-axis and go counterclockwise. And then you land in a quadrant, and then you need to know this is the principal angle from the principal arm to the terminal arm, and beta is the reference angle. And beta is usually an acute angle, so you want to make a note of that. Beta is always going to be an acute angle. So these are the main concepts, guys, for this particular lesson. I think these are very straightforward. A lot of it is review from grade 11. Let's just review it. The first thing we have are our special triangles, converting from degrees to radians. Then we have our trigonomic ratios and our Pythagorean theorem, all which are the same that we've learned from the past, and they only deal with right angle triangles. Very important. Then we got the CAST rule, so the CAST quadrants, cos is positive, all is positive, sine is positive, tan is positive. And we know the hypotenuse is always going to be positive, but the x or y could be positive or negative, depending on which quadrant you're in. We also know not to do this, right? Don't make your triangles in reference to the y-axis. And the last thing is, what is the difference between a principal angle and a reference angle, a principal arm and a terminal arm, right? And we start in the x-axis, the positive x-axis, and we go counterclockwise. So this is just an outline of all the concepts, guys. If you found this helpful, feel free to drop a thumbs up, like the video, share this video to your friends if anybody you know is struggling with this course. If you need tutoring, feel free to click the link in our description. Our team would love to get in touch with you guys and help you out with this course. So yeah, feel free to subscribe, and we'll see you in the next video.